this is the last part of 7.6. Now we're putting it all together. So for any kind of factoring of whether it's binomials or polynomials, you want to look for the greatest common factors first, the GCF, which is right here. Let's see. Look for the GCF first. Then you factor that out, and then you check the rest of the work and see if you can do a difference of squares, or in the future there are other properties that you can use. So let's look at some examples here. Number 21, 2n squared minus 72. Even numbers, so I know I can take the 2 out, right? 72 divided by 2 is 36. Now, inside that parentheses, I can rewrite this into a difference of squares. N squared minus 6 squared. So n is my A, 6 is my B, and I can easily separate that apart into n plus 6 times n minus 6, a pair of factors. Number 22, same thing. I have even numbers. So then I factor that out using each term divided by the common factor. So I have 9x squared minus 25. Understand how I got these two values. I got it from using the original term divided by my factor of 2. Okay, now I rewrite the inside into 3 squared, whole thing squared, and then 5 squared. Whatever I didn't touch, I bring it down. Now I have my difference of squares. A plus B times A minus B, right? Number 23, is there 4? I don't think so. So even numbers, I'm going to take 2 out. So 32s squared divided by 2 is 16x squared. 18 divided by 2 is 9u squared. So if I rewrite the inside, I should have 4s squared minus 3u squared. All I did was I rewrote it. Remember, I should have written it here. Sorry about that. All I'm looking for at this point is a squared minus b squared. Something squared minus something squared. Then I can factor that into a plus b times a minus b. So it's 4s plus 3u times 4s minus 3u. Number 24, 25, 26 are exactly the same. So I'm going to leave it to you to solve these three by yourself. Okay. And then and I will check for accuracies when you submit the work, so make sure you do those. Number 27 is a little bit more challenging, so I'm going to do it together with you. I have, from these two numbers, integers, I definitely have 5, right? Also notice that I've got common factors in the variables, so I take the lower degree, n squared. So 80 n raised to the 4th power, 80 n raised to the 4th power divided by 5 n squared. That should be 16, so that's 16. Then 4 minus 2 is n squared. 125 divided by 5 should be 25. N squared divided by n squared cancels out. So now if I rewrite this, it's 4n squared minus 5 squared is the inside. So my final answer is to bring this down, 5n squared. Then inside is 4n plus 5 times 4n minus 5. So compare this to what you've practiced above. The only difference is that now we have common factors in variables as well. So take it out. Simplify it as much as possible. That's why when we were learning in classrooms, I kept saying I love cancellation, because the more you cancel, in this case, the more common factors you find, the easier it gets for the remainders. because, things are getting smaller and smaller. It's much easier to deal with them in pieces. Number 28, between 8 and 32, I think it's 8 coming out. What do I have in common in the variables? It's just 1y. So 8x squared y divided by the common factor. I only have x squared left. And then 32 divided by 8 is 4. Y cubed divided by y, 3 minus 1, I have y squared, right? If I were to rewrite this into a square, it's 2y whole thing squared. And now it's 8y times x plus 2y times x minus 2y. Okay, here I'm going to do it on this side. I want to explain something with respect to this example here. When we have 4y squared, I want to take a square root of it. That's how I have 2y, which means 4y squared equals 2y whole thing squared. Okay, you cannot write like this without the parentheses. Notice, how can 4y squared be the same as 2y squared? It cannot be, right? That's the reason there. So, okay, let's continue. I will try to finish the rest of it with you because these are pretty challenging. I may leave you with one that's for you to do independent practice, and then there are some homework practices as well. Keep in mind, at any time that you are lost, pause the video, rewind, understand it. If you still don't understand it, you can move on, but send me an email or post it in the discussion board. Okay? Actually, I will leave 29 because it's relatively easier. Number 30 is a little harder. 3, I'm going to take 3 out. I don't know if I can, so let's try it. 147 divided by 3 is 49. This actually can be rewritten as 7 squared. So this is not as hard as I thought. A plus b times a minus b. Number 31, I have a 4 in there. So it's 4k. I have a k as well. So k cubed minus 1, it's 4k squared. 100 divided by 4 is 25. K divided by k is 1. So I can rewrite this as 2k squared minus 5 squared. So now my answer is 4k times 2k plus 5 times 2k minus 5. Okay, I'm going to leave 32 with you to complete as well. It's not too hard, it's tedious. Take it one step at a time, and then we'll go from there. All right, guys, finish this, and as well as the homework practices that I indicated on PowerSchool Learning. I will see you later. Bye-bye.